Hey guys, in this video we're going to be looking at another measure of variation called the mean absolute deviation. And the mean absolute deviation is the average distance between each data value and the mean. So now we're adding another statistic to our list of things we've learned on how to summarize a set of data. And I've got them organized here. We have measures of center that we talked about. And those are ways to find a typical value in a data set or a way to summarize the data set with a single number. And we use the mean or the average, the median, and the mode. And then we talked about measures of variability, which were measures of how spread out our data is or how consistent our data is. And we talked about the range and the interquartile range. And the interquartile range used the median and the quartiles to get that value. So today we're going to add one more measure of variability, and that's called the mean absolute deviation, or the MAD. So how do you calculate the mean absolute deviation? Well, the first thing we want to do is find the mean of our data set, find the average, because we want to find out how far away all of our data numbers are from the mean on average. So we want to find the mean, and then secondly, we want to calculate the difference or the distance between the mean and every data point. We want to list how far away from the mean is every point in our data set. And here we want to use the distance, so it's the absolute value. We're not going to be using any negative numbers here when we find the difference between the mean and the data points. We're going to find out how far away it is using a positive number. And then lastly, we're just going to average all of those values. So let's look at an example. This table shows the points scored by a basketball player in his last 7 games. We want to find the mean absolute deviation and describe what the mean absolute deviation represents. What does it mean when we find this measure of variation? So again, step 1 is to calculate the mean or the average. And so the first thing we would have to do is find the sum of all of these numbers, and I've done that. And the sum of all of the points scored is 126 in those 7 games. So the mean is going to be 126 divided by 7, which is 18 points per game. Now we want to find the difference between the mean and each data point. So how far away was each game score from the average? So I'm just going to go right through these and list them. So we had a 17-point game, and that's only 1 point away from the mean. He had a 22-point game, and that is 4 points away from the mean. The mean is 18. 4 points away from the mean. A 17-point game, which is 1 point away from the mean. A 30-point game, which is 12 points away from the mean. A 15-point game, which is 3 points away from the mean. Another 17-point game, which is 1 point away from the mean. And an 8-point game, which is 10 points away from the mean. So then lastly, our last step is to average all of these values. So I want to find the average distance from the mean. So I'm going to add all of these values up, and they add up to 32. So my average is going to be 32 divided by 7, which is 4.57. And this is my MAD. So what does that tell me? It tells me that on average, his games, the games that he played, he scored within 4.57 points of the mean. So his data values were on average about 4.57 points away from the mean. So again, this is a measure of how spread out or how consistent our numbers are. So again, an MAD of 0 would mean that all of his games were exactly the same number of points. So none of the points deviated from the mean at all or were different from the mean at all. So again, just like the IQR and just like the range, a smaller MAD tells me that my data values are more consistent. So we can compare the mean absolute deviations for 2 data sets. So we can use this to compare two sets of data to see which ones are more consistent or which ones vary more. A data set with a greater mean absolute deviation has data values that are more spread out from the mean than a data set with smaller mean absolute deviation. So just to repeat what I said in the last slide, a larger MAD says that your data set is less consistent or more spread out. A smaller MAD means that you have a consistent set of data. So let's take a look at these two data sets, and we're going to compare the variation in heights of the girls and boys in Glee Club. So the dot plots show the heights of the girls and the boys in Glee Club, and we want to find or compare their variations. Again, we're not comparing their measures of center. We're not saying who's taller. We're just saying which data set or which group is more consistent or less variable in their heights. So step one was going to be find the mean or find the average. So I have all of the heights listed here from least to greatest from the dot plot, and the sum of the heights is 504, and there are 8 girls in Glee Club, so that gives me an average height of 63 inches. And then again, step one for the boys, if I find the sum of all their heights, the sum of all their heights is 520. And if I divide that by the 8 boys, I get an average height of 65 inches. So that's a measure of center. Now we want to use that to find our mean absolute deviation. So I need to list how far away each girl's height is from the mean. So I'm just going to go right down the line here for all 8 heights. So this first height for the girls, 59 inches, is 4 inches from the mean. 61 is 2 inches from the mean. 62 is 1 inch from the mean. 63 is the mean, so that's 0. 64, 64, and 64, those are all 1 inch away from the mean. And the tallest girl, 67, is 4 inches above the mean. And then for the boys, do the same thing. Find out how far away each boy is from the mean. The shortest boy is 60 inches. That's 5 inches from the mean. 61 inches is 4 inches from the mean. 62 and 62 are both 3 inches from the mean. 64 inches is 1 inch from the mean. 65 is the mean, so that's 0. 72 inches is 7 inches from the mean, and 74 inches, the tallest boy, is 9 inches from the mean. And then lastly, I want to average all of those values to find my MAD. So I find the average of all of these numbers. If I add all these up, they add up to 14. And if I divide that by the 8 girls, I get 1.75. This is the MAD, or the mean absolute deviation, for the girls. And then same for the boys. If I add all of these up, I get 32. And 32 divided by 8 is 4. So the boys have an MAD of 4. So that tells me that the boys have a larger variety of heights. On average, the heights are further away from the mean. That means that their heights are more spread out or less consistent. So I could conclude that something like the boys in Glee Club have a larger variability in their heights. Something like that. There's a lot of different ways we can summarize that. That's one way to say it. We could also say that the girls' heights are closer together or more consistent, or the girls' heights are more similar to each other than the boys' heights, anything like that. And again, that's what we're talking about when we talk about variability, how consistent or how spread out our data is.